Hello guys, in this next video we're going to be going over projectile motion. So what does it mean when we throw a ball, a marker, whatever it is, straight up into the air, and how can that be modeled graphically? So how could we're launching a rocket, we're throwing a ball, we're trying to figure out how long does it take for that ball to be in the air, when does it hit its maximum height, and we have problems like this. So with this problem we have John throws a baseball from the top of an 80-foot tall building with an initial velocity of 64 feet per second, which is modeled by the equation f of t equals negative 16 t squared plus 64t plus 80. So I'm giving you guys the equation, but just to go over it real quick, how we get each of these pieces in the equation. Negative 16t squared is always going to be your leading term for projectile motion problems. So if you're talking about something being thrown in the air, it's just kind of been decided by science or whatever, that negative 16t squared is going to be your leading term. And then after that, your velocity goes next, so 64 feet per second, that goes next. And then lastly, your initial height, that should be pretty obvious, is your constant. So we have questions like this. After how many seconds does the ball hit the ground? And what is the ball's maximum height? So to understand these questions, we really need to know what the graph looks like. Just think about what the graph looks like. So if we're trying to graph this situation right here, we could model it kind of like this. He's up here, let's say, at the top of this building. That's him up here. Little stick figure. And that's 80 feet high. He's throwing the ball 80 feet high. He throws that ball up into the air, and then down, and it hits the ground. So what points are we looking for? We're looking for, after how many seconds does the ball hit the ground? The ground is right here. This right here is just the ground. We're looking for when it hits the ground, so we're looking for, what is this right here? And we're looking next for his maximum height. So we're looking for this point right here. And so these points should look really familiar, especially because we just went over characteristics of graphs. Remember, this is just a quadratic equation with a negative leading term. And so that's why the graph looks like this, because he throws it up, it reaches its maximum height here, and it goes down, hits the ground. Those 2 points aren't just random points in the graph. If you guys remember, this point is actually our vertex, the maximum point on our graph. And then this point is just where it's hitting the x-axis, right? This is like our x-axis, it's our x-intercept. So we're looking for 2 points. We're looking for the x-intercept, and we're looking for the vertex. Which mathematically, the x-intercept is just talking about how long does it take to hit the ground. The vertex is saying what's the ball's maximum height. So how do we figure those 2 things out? So first off, how do we find the x-intercept? Well, we do that by setting this equation equal to 0. Because when this equation equals 0, that's just talking about when y is 0. If we think about the definition of x-intercept, that's just the value when y is 0. So what we're doing is we're taking our equation, negative 16t squared plus 64t plus 80, and we're setting it equal to 0. And so now, if we tried solving it like this, it'd be a beast of a problem. So we need to remember greatest common factor. Do these 3 numbers, do they share a GCF that we could move out in front of our equation, and it will give us a simpler equation of factor? And you should notice that yes, they do. These all have a factor of 16 or negative 16. So we're going to factor in a negative 16. So we take out negative 16. When we do that, we're just left with t squared here. And then 64 divided by negative 16, that is just negative 4. T. And then 80 divided by negative 16, that's just negative 5. And this all still equals to 0. So now we have a much easier equation to factor. This one we can factor very easily. So let's go off to the side. Make our x, we have negative 5t squared, we have negative 4t. What 2 numbers add to be this, multiply to be this, and you should get negative 5t and then just 1t. Negative 5 plus 1 is negative 4. Negative 5 times 1 is negative 5. And so we can make our box. Make sure this is in the shot. Perfect. So we have t squared, we have negative 5, we have 1t, we have negative 5t. And so we fill this out, we have t, 1, negative 5. And so this just factors into negative 16 times t plus 1, t minus 5. And this all equals 0. And if you guys remember with the factoring video, from here, we're solving two different equations. So we're splitting these in half, and we're solving two separate equations. T plus 1 equals 0, and t minus 5 equals 0. And then t minus 5 equals 0. So solve this one, we just subtract 1, we get t equals negative 1. For this one, we just add 5, so plus 5, we get t equals 5. So now we get two answers. And now, once again, we can't just circle these answers because we're talking about a word problem. We're talking about how many seconds it takes a ball to hit the ground. So now we have to contextualize these solutions because we know the ball only hits the ground once. So now we need to think which one of these answers makes sense. Does it take the ball 5 seconds to hit the ground, or does it take it negative 1 seconds to hit the ground? So when you get to this point, you're going to get one negative answer, one positive answer. The positive one is the only one that matters because it can't take negative 1 second for the ball to hit the ground. So this is meaningless. All we care about is the positive answer, which tells us that it takes 5 seconds. And that is our final answer for that one. Now, over here, what is the ball's maximum height? I said we got to find the vertex to do this. So how do we find the vertex? We remember we got to start off by finding the axis of symmetry, and then from there we plug that into the x value from our axis of symmetry into our original equation, and we get our vertex. Okay, so I would say that this is easier. We could use this equation right here, or we could use this equation right here. So I say to figure out our axis of symmetry and our vertex, we use this one where we already factored out the negative 16. But you can do either way. So we're using the equation negative 16 times t squared minus 4t minus 5. And so to find the axis of symmetry, we're using the equation x equals negative b over 2a. Negative b is just 4 over 2a is just 1. And so this just equals 2. Since now our a is just 1, our b is negative 4, our c is negative 5. And so we get our axis of symmetry is at x equals 2. Or it's, yeah, should be t. Now we need to plug this in for t in our original equation. So we have negative 16 times, and then we plug in 2. So 2 squared minus 4 times 2 minus 5. This is just negative 16 times 4 minus 8 minus 5, which is just negative 16, negative 4, negative 9, times negative 9, which is just 144, I think, right? So this is just 144. Yeah. So our vertex for this graph is going to be at 2, 144. And now we need need to contextualize in terms of the problem. It says, what is the ball's maximum height? Well, we know it's just whatever the y value is of the vertex. So the ball's maximum height is 144 feet. If we wanted to be a little bit more specific, we could also say that it reaches its height at 2 seconds. So at 2 seconds, the ball's gonna reach its maximum height of 144 feet. And that is it. That's how we do this beast of a problem.